Hello everyone, and welcome to numerical series of advanced electrical machine. Today our numerical problem is the input power to a 6-pole 3-phase 50 Hz induction motor is 42 kilowatt. Speed is 970 rpm. The stator losses are 1.2 kilowatt and friction, and windage losses 1.8 kilowatt. Find rotor copper loss, uh, efficiency of motor. First of all, already given pole 6, frequency 50 Hz, and n is equal to 150 by p, 120 by p, that is 120 into 50 by 6. So 1000 rpm, divide this 1000 by 60, so we get 16.667 rps. Motor speed n equal to 970 rpm, that is 16.166 rps. And we know slip equal to ns minus nr upon ns, that is 1000 minus 970 upon 1000, 0.03. Power input to the stator P1 equal to 4 kilowatt. So power input to the rotor P2 equal to P1 minus stator loss, that is 4 square, that is 42 minus 1.2, that is 40.8 kilowatt. And rotor copper loss S into P2, that this is 0.03 into 40.8, that is 1.22 1.324 kilowatt. And P out equal to P2 minus rotor copper plus friction plus windage losses. Then 40.8 minus 1 point, by getting this sum and subtracting from 14.8, that is 37.776. And BPS equal to motor output in kilowatt upon 0.7355. So 37 point motor output we have already found 37.776 upon 0.7355 equal to 51.36. And efficiency, motor efficiency is output upon input into 100%. Put the value of output and input, then we can get the efficiency of motor, and the efficiency of motor is 89.94%.